In the last video, we took a look at MCP from a theoretical perspective, so what it is, what it can do, and why we need it. And in this video, I would like to get our hands dirty and actually implement an MCP server using Python. So this will be a local MCP server which communicates through standard input-output, and we will add two tools. So one tool is for adding two numbers, and the other tool is for adding new content to a file. We will also explore prompts and resources, and let's just jump into our shell. So this is our shell. We can see that I created a new empty folder. And the first thing that we need to do is to install UV. In this case, it's already installed, UV -- version. Yep, it's installed. And now the next thing is to add to initialize the MCP server demo. So we see that we got a new directory here. We can hop into it and we see that 3 files have been created. Now we need to add the MCP package CLI, and this will take a while. Perfect. So now if this is done, we can open our files in our favorite IDE. In this case, I'm going to use Cursor. Here you can see all the files that have been added, and we are interested in modifying main.py. The first thing that you're going to need to do is to import the MCP library, fastMCP, import fastMCP. Then we're going to import types, the annotations, tool annotations, and we're going to instantiate our MCP object, fastMCP. We're going to call it demo and JSON response equals true. And now we are ready to define our first tool. So I'm going to say mcp.tool, define addition, takes in an int a and an int b, and it returns an int, return a plus b. So this function will just return the addition of a and b. And now we can also specify more properties of this tool. So to do that, we can do annotations, tool annotations, and then I simply copy these properties in here. These will give the LLM more context or more information about this tool. Destructive hint specifies if this tool has some destructive energy or if it's more harmless. In this case, it's a simple addition, so relatively harmless. We can set this to false. Then we have the open world hint, and this hint specifies if this tool touches external systems. In this case, this is not true, so we set it to false. We have the idempotent hint. This means if we call this tool multiple times, will we see different results, even if we call it the exact same way. In this case, this is not the case. We simply return the addition, so that's fine. And then we have the read-only hint, which is set to true. Since we don't touch anything, we don't write to any output, we simply add these two numbers. So now we're going to add our second tool. So mcp.tool, define write string, and it returns none. And we say with open output.txt, a for append, and then the encoding is gonna be UTF-8 SF, and then we say f.write s plus the new line character. So this will simply add or append new content to a file, to the file output.txt. We can also, again, paste in our annotations. So now these annotations are different, of course. We have the destructive hint set to false because we simply add more content to a file. It's not really destructive. We have the open world hint set to true because we touch systems which are outside of this function. We have the idempotent hint set to false because if we run this tool multiple times, we will keep on adding more content to the file. And the read-only hint, of course, also set to false. So these are our MCP tools, and now we can also add prompts. So to do that, we do mcp.prompt, and we define a greet user function. It takes in a name, a style, string, and it returns a string, which is the prompt. So we say styles is a dictionary. So we can simply copy this from here, and then we simply return styles get and then style, which is the preferred style that we want. And then as a backup, we say style friendly, perfect. And then we say good for someone named, and then name. Perfect. So this will return a prompt depending on the style that we submit and the name. And now we can also add a resource, mcp.resource, let's say greeting, name, and we define it as get greeting name string, and it will return a string as well. And it will simply return hello and then the name. Okay, perfect. So when we call this resource, it will simply return a string hello name with the name that we provided. Now we can delete this main function here, and we simply call our MCP object, mcp.run, transport standard input output, and that's it for now. So now we are back in our shell, and in order to run our MCP server, we need to execute this command mpx and then the model inspector, and then also uv run -- with mcp main.py, which is our Python file that we have edited. Then we can open this tab. We can connect to our MCP server. Let's see what's going to happen. Okay, we are connected. We can list the tools here. We have the add tool. We can add 3 and 5. And we get 8, which is very good. We can use the write tool, but before doing that, I would need to add a file, output.txt. We move it into the right place. Already exists. Okay, very good. So we don't need to do it. It's empty now. That's good. So let's run this tool. Let's check it. Let's check it here. Yeah. So this works as well. The MCP server now writes to our file as we intended. And now we can also list our prompts. So we go on the prompts, click here, and then enter our name, test, and then the style will be friendly. Let's see. And we can see, please write a warm, friendly greeting for someone named Test. We can also check casual, and this works as well. And last but not least, we take a look at resources. We list a template, get greeting, enter the name, test. And here we also see our resource. So now we can see that we have resources, prompts, and tools installed on our MCP server or implemented in our MCP server. And the next step would be to create an MCP server which is not local, but remotely accessible. So this is going to be topic for our next video, and thank you for watching.